Hey everyone. So in this video, I'd like to talk about some problems involving a balance beam, some bags, and some coins. And so these problems are meant to serve as motivation and intuition for how we will solve equations in the upcoming videos. And so let me paint a picture of how each of these problems will look. So in each problem, there's going to be a balance beam and some coins on either side of this balance beam, as well as bags that contain coins on either side of this balance beam. And so when we look at a balance beam and there are going to be some bags and coins, one big point is that all of the bags on a balance beam are meant to contain the same number of coins. And we're going to start off by looking at this balance beam and assuming that the beam is balanced, that everything on one side of the balance beam weighs the same as everything on the other side of the balance beam. And so our goal will be to determine the number of coins in each bag by recognizing that this balance beam is balanced and trying to make the situation a little bit simpler while maintaining the balance on the beam. And so this is a lot to say. Let me just go through an example and I think it'll start making some sense. So here, I'm going to draw a balance beam. I'm going to draw a balance beam here. And on one side of this balance beam, there's going to be a bag. And in this bag, there's some coins. I don't exactly know how much. I'm going to assume the bag itself doesn't weigh anything. Just, it's a way of holding some coins in a bag. And then there's some coins on the other side. And so our task is to look at this balance beam and try and decide how many coins are in each bag. And in this case, there's only one bag. And so if these two sides of the balance beam are supposed to weigh the same, if this left side of the balance beam weighs the same as the right side of the balance beam, and I'm assuming the container itself isn't going to weigh anything, just what's in that bag, well, for them to weigh the same, there has to be 3 coins within this bag. That's the only way this balance beam is going to be balanced. Right, so this is really what I meant by all of what I described above, is that we've got a balance beam, we're assuming it's balanced, and we're just trying to make sense of how many coins are in each bag. In this case, for the balance beam to truly be balanced, there has to be 3 coins in the bag. Okay, so this might have felt like a slightly silly example, but I just wanted to use a very, very simple example just so that we can get comfortable with the idea of what we're doing. But let's look at another, maybe a little bit more interesting example. So in this example, the left side of the balance beam contains 2 bags of coins and 3 additional coins outside of the bags. Whereas the right side of this balance beam, it contains 1 bag of coins and 6 additional coins outside of the bag. And we're assuming all of the coins in each of the bags, there's the same amount in each of the bags. And so the beam we're also assuming we're assuming it's balanced as well. So how can we figure out how many coins are in each bag? Well, this is a balance beam, right? So we can take away the same amount of weight from both sides, and the beam will still be balanced. And maybe that will kind of clarify what we're looking for. So here, if I take away 1 coin, maybe I'll use red here. If I take away 1 coin from the left side and 1 coin from the right side, I'm taking away the same amount of weight. The balance beam should still be balanced. Right, well, there's no harm in taking away another coin from each side, and even another coin from each side. Right, so now we have 2 bags on one side, 1 bag on the other, and then 3 coins on top of that. And here, the balance beam was balanced to begin with. It's still balanced because we took the same amount of weight off from both sides. And actually we said that we're assuming each bag contains the same amount of coins. Each bag weighs the same as any other bag. So actually I can take away this bag from the right side and this bag from the left side, and my balance beam will still be balanced. And now we're saying that the left side weighs the same as the right side. Well, this left side is just one bag now, whereas the right side, it's got 3 coins only left over. And so the only way this would really work out is if each bag contains 3 coins. So here, let's take a look at another example. And this one, I encourage you to pause the video, try out the ideas from the previous example to see if you can determine how many coins are in each bag here. So again, we're assuming things are balanced. The left side weighs the same as the right. All of the bags contain the same number of coins. Let's start off by doing the same thing, taking off the same number of the same amount of weight from both sides. So I can take away 2 coins from both sides, and I'm still going to have a balanced beam. I can take away, one of these bags and one of these bags, and I'm still balanced. One of these bags and one of these bags, and we've still got a balanced beam, and another one of these bags and another one of these bags, and then we've yet again got a balanced beam. And this time, we see that we only have 1 bag left here. There's no more bags elsewhere on this balance beam, and that on the other side of the balance beam, there's how many coins? There's 5 coins. And that's all that's left. We're saying that 1 bag must weigh the same as 5 coins, and since the container, that bag itself doesn't weigh anything, just what's inside the bag, that bag must contain 5 coins too. So each bag must contain 5 coins. So let's do one last example here. So in this example, there are 4 bags on the left side. There's how many coins? There's 5 groups of 4 coins on the right. So there's 20 coins on the right. So 4 bags on the left, that weighs the same as 20 coins on the right. Now, how do we decide how do we figure out how many coins are in each bag? Well, unfortunately, we can't do the same thing we did in the previous examples, right? I don't know how many coins are in each bag, so I can't take off the same amount of weight from both sides because I wouldn't know how many coins to take away. Well, one thing we can do is we can notice that, 1/4 of the weight of the left side should be the same as 1/4 of the weight of the right side. Right, if I take the weight on the left side and I divide it by 4, it should be the same as the weight of the right side if I divide the right side by 4. Right, so 1/4 of the weight will just be 1 bag. And 1/4 of the coins on the right, that'll be 5 coins. Right, we can kind of imagine that each bag would have to contain 5 coins if this was going to be balanced. And so that's our conclusion, is that each bag must contain 5 coins. And the idea is that 1/4 of the weight of the left side should be the same as 1/4 of the weight of the right side if they weighed the same to begin with. So now that I've given you some exposure to these kinds of problems, I'd like you to pause the video and stop and work on this activity that I uploaded. And so there you'll see more problems, a lot like the ones we've covered, that you can practice on your own. And in the rest of the video, we'll go over some of those problems, but I would really like you to pause here and start trying out some of those problems before you resume the video. Okay, so I'm going to assume from here that you've already taken a look at this activity and tried out the different problems, and that we're going to go over this together to just review your answers. So the first problem on this activity says that one side of the balance beam contains 3 bags, and then on the other side of the balance beam, there are 24 coins. And so how can we figure out how many coins are in each bag? Well, again, the two sides of this balance beam don't share anything in common. I can't take away the same weight from both sides because I don't know how many coins are in each bag, so I can't really do something fair to both sides. But one thing I can do is I can recognize that the left side just contains 3 bags, and so I can divide that away to look at 1/3 of the weight as being the same as 1 bag. And if I look at the right side, and I look at 1/3 of that weight, well, 24 coins, 1/3 of 24, or dividing 24 by 3 gives me 8 coins. And so if the two sides weigh the same to begin with, well then that means 1/3 of the weight of the left side should be 1/3 of the weight of the right side. So one bag should weigh the same as 8 coins. Each bag contains 8 coins. So in the next problem, it says that there are 3 bags and 29 coins on one side. So I'm just going to quickly draw the balance beam here. These numbers are getting a little large. 29 coins, maybe that's a little too much to draw. So I'm just going to draw 3 sets of bags, and then I'm going to draw 29 sets of coins. It's not 29 times 0, it's 29 times coins. Just one of the little circles that I've been drawing. And then on the right side, I'm going to draw 4 sets of bags. I'm just going to write it like that, 4 times the number of bags, or 4 times bags. And so if we want to do the same thing that we've been doing so far to try and get a clearer picture of how many coins are in each bag, we can take away the same things, the same weight from both sides. Well, if there are 3 bags on the left and 4 bags on the right, well, they have 3 bags in common. I can take away 3 bags from both sides. And if I take away 3 bags from the left side, I've gotten rid of all my bags. And if I take away 3 bags from the right side, well, then all of a sudden there's only one bag left. Maybe the 1 times is confusing. I'll just write that there's just 1 bag on the left, or 1 bag on the right. And there's 29 coins on the left, and that's it. And so what we're saying is that if these are going to weigh the same, then 1 bag must contain the same number of coins as 29 coins on the left. So here, each bag we know contains 29 coins. And I encourage you to check, imagine 29 coins in each bag to see that we would get a balanced balance beam. But here I'm going to move on to the next example. So here it says there are 11 bags and 25 loose coins on one side of the balance beam. So if I draw a balance beam out, there are 11 bags, 11 sets of bags, and 25 sets of coins on one side, and then there's 4 bags. I almost wrote B for bags. Maybe I'll make this a little clearer. It's just a bag. And then 60 sets of coins on the right side. So if we do the same thing, we take away the same amount of weight from both sides. Well, there are 4 bags in common on both sides of this balance beam that I can lift off and feel confident that my beam will still be balanced. So I'm going to take away 4 sets of bags from the right. And if I take away 4 sets of bags from the left, I'm left with 7 sets of bags. Now next, there's some coins in common too that I can remove from this balance beam and still have things be balanced. There's, one side has 60, one side has 25, so I can take away 25 and still feel okay about things, right? If I take away 25 coins from both sides, well, the left side won't have any coins, just bags. And the right side, well, that'll have 35 sets of coins. And so across the 7 bags on the left side, I know that's going to weigh the same as the 35 coins on the right. And so each bag needs to contain 5 coins if they're going to weigh the same. Right? From here, really what I'm doing is I'm dividing the weight of both sides by 7 to get 1 bag and to get 5 coins. And so here, what this tells us is that each bag must contain 5 coins. So in this example, it says that there are 5 bags and 24 coins on one side. So 5 sets of bags and 24 sets of coins. And then on the other side, there's going to be 51 sets of coins and 2 bags. So we can take away what's in common between each side, right, and still be left with a balanced beam. So I'm going to take away 2 bags from each side, and that leaves me with 3 bags on the left and no bags on the right. Our beam is still balanced. And then I can take away 24 coins from each side, and there's no more coins on the left. Taking away 24 coins on the right will leave us with 27 coins. And if those are going to weigh the same, then I really need to split up those 27 coins across the 3 different bags. Or I can imagine dividing the weight of the left side by 3, and that would need to be the same as dividing the weight of the right side by 3 to tell us that each bag contains 9 coins, right? 27 divided by 3 is 9. So each bag contains 9 coins. So here I have 2 more problems. One of these problems says, suppose your friend has a balance beam with some coins and bags on both sides of the balance beam. This problem asks, what advice would you give your friend so that they can determine the number of coins in each bag? And of course, it would be ideal if you can look into each bag and see the number of coins, but using what we know now, is there another approach? Well, here, in all of the problems, we had a balance beam, there were some coins and some bags on both sides, and it was simplest if we first removed what was in common between both sides. Right? Maybe there's some coins on the left and some coins on the right, but we can kind of take away the redundancy, take away what's in common so that there's only coins on one side of the balance beam. And we can do the same thing with bags too, right? If there are bags on both sides, we can kind of take away the same amount of bags from each side, and we'll still be left with a balanced beam. So first things first, take away what's in common from both sides of the balance beam. Right, and so if we've taken away everything that's in common, then there shouldn't be bags on both sides. Otherwise, there'd be more to take away that's in common. So there should only be bags on one side of the balance beam. And similarly, there shouldn't be coins on both sides because we've also taken away what's in common. If there are still coins on both sides, we could take away more, right? So there should only be coins on one side of the balance beam too. So we've only got bags on one side, coins on the other, if at all. And so the next step would just be to divide by the number of bags. From both sides. Right? Earlier in one of the examples we saw that there were 7 bags on one side and 35 coins on the other. We divided both sides by 7 to see that each bag needed to contain 5 coins. And so this is the general approach, is that we want to take away what's in common, we want to subtract away what's in common from both sides of the balance beam, and then we'll have some bags left over, some coins on the other side. We can divide the coins across the number of bags, in other words, divide by the number of bags, and then we'll see how many coins belong in each bag. And so let's take this step-by-step advice and use it to address this next question. That if there are 13 bags on one side and 86 loose coins outside of the bags. And then on the other side of the balance beam, there's 20 bags and 37 loose coins. Well, the first step was to take away what's in common, right? So here I'm going to take away how many bags they have in common. They have 13 bags in common. So taking away 13 bags from the left side, I have no more bags. Taking 13 bags away from the right side, I'm left with 7 sets of bags. Now there's 37 coins on the right and 86 coins on the left. I can take away some coins in common and make this a simpler yet still balanced problem. And so if I take away 37 coins from both sides, well, taking away 30 brings me down to 56 on the left, but then taking away that additional 7 brings me down to 49, right? 49 sets of coins on the left. If I take away 37 coins on the right, I have no more coins, just bags. And then from here, if I have 7 bags on the right and that weighs the same as 49 coins, and each bag has the same number of coins, well then I can divide those 49 coins across the 7 bags to see how much each bag contains, right? And so dividing by 7, I get 1 bag on the right. Dividing by 49, I get 7 coins on the left. Right, so each bag contains 7 coins. All right, so there are other problems on this activity. I decided not to go over them because I think they're a little more challenging and probably not the most important to really dig into. I definitely encourage you to try them out, but I'm going to stop this video here. One more thing I'd like to say is, I started this video off by saying that this balance beam and this bag and coin situation, it's a great analogy to think of when you try and solve equations. And so in the next videos, we're going to talk about equations and then keep this analogy a little bit in the back of your mind. I think it'll help really solidify what we're doing when we try and solve equations.